that a moving object has. Trains obviously have a ton of it. Cars have energy, kinetic energy, and then as you double the velocity, you actually quadruple your energy. You'll see that. You can store energy in the form of a flywheel. Flywheel is just a spinning piece of metal that's heavy, right? Bullets are energy storage devices, right? I want to hurt that thing over there, right? You store the energy in a little chunk of lead, and it goes over there and hurts that thing over there, right? How about hammers? Think about it. Hammer is just a kinetic energy storage device, right? If you were Superman, you could just push nails in, just like, right? Yeah, couldn't you? Just like, there we go, right? But the rest of us take a hammer and we store kinetic energy into it, and then it does work on the nail, right? It hits the nail and pushes it with much more force than we could do with just our bare hands. I mean, I can push them in with my bare hands, right? But, you know. And then the final one is thermal energy. Thermal energy is it's really not a different type of energy. It's just so random that we call it a different type. Okay. So the way to think about thermal energy is, imagine a bunch of, you like my example? Hot stuff, right? They actually use one idea for storing thermal energy. When you see people talking about storing thermal energy, is that you actually melt stuff like salts. Like sodium chloride can be melted at like white hot temperatures. And so you use like solar concentrators to melt this stuff. You store it down in some reservoir, and then when you need that energy, say at nighttime when the sun's not shining, you tap it out of that reservoir. But one way to think about thermal energy is just think about a bunch of, this is like a crystalline solid, like a salt crystal, right? And these are molecules or atoms in that salt crystal. Think of them as being joined by little springs. Right? So thermal energy is just their motion. They're like, hot is like this, cold is like, yeah? Hot, cold, hot, cold. I'm going to keep doing that till you laugh, right? Okay, so they're just sitting there bouncing back and forth. They either have kinetic energy because they're in moving, or they've come to the point where they're about to turn around and go back, and they've got potential energy stored in the bonds, right? So a mass on a spring bouncing back and forth is some combination of potential and kinetic energy, and that's what we're talking about there. Questions about types of energy? It's exciting, isn't it? Magnetic energy. What would that be? Potential. I think that's potential energy. The energy stored in a magnetic field. Yeah, it's magnetic potential energy. Not so much. You know, I mean, that's a different force. It's an electromagnetic force versus a, right? And then the forces, because if F is really big, right, then the energy associated with it is going to be really big. So nuclear energy is so tremendous because strong nuclear force is so strong, right? Whereas when we do chemical reactions, we're just talking about the electrical force, electromagnetic force, which is relatively weak compared to the nuclear force. The example would be, in a given reaction, you can typically get tens of electron volts. It's a type of energy out of a particular molecule, like TNT or something like that. It might be tens of electron volts. Okay. In a particular, if you have a one atom of uranium split, you get 200 million electron volts, right, per atom. You can almost feel that. It's like, ooh, ouch, right?